So we're going to talk about permaculture versus organic production systems. Background here, Bill Mollison and David Holmgren coined the term permaculture in the mid 1970s as a contraction of the words permanent and agriculture. And the philosophy behind this was that it's a direct response to perceived degradation of ecology, culture, and health in the last century that resulted from extractive and controlling processes of an industrialized society. So Mollison was really more the practical side. He was the how-to for agriculture practice. And for more of an introduction to permaculture, this link will take you to a blog spot. It's basically a book on permaculture. Holmgren kind of came up with the overarching principles of permaculture. He found this to be more applicable to society as a whole, more thought and discussion provoking. He was really more the philosopher of the two. But there were other permaculturalists that gave rise to the movement that are very important. And they're listed here with links to learn more about them. And it's not just, permaculture doesn't just include crops or produce, but it also includes animals. And so you'll see a lot of that throughout the people listed. So some permaculture definitions that become important. It's a method of thinking for designing any system. It is not value-based, but it's evidence-based. Sciences and theories that are backed by testable evidence that are found in the natural world. It's about applying information to the design of sustainable systems. It's a theory of design which uses biological and ecological systems as models to create permanent and sustainable agriculture systems. It's about designing sustainable human settlements. It's a philosophy and an approach to land use which weaves together a microclimate, annual and perennial plants, animals, soil, water management, and human needs into an intricately connected and productive communities. So the word permaculture was coined by Bill Mollison and Holmgren in the mid 1970s to describe an integrated, evolving system of perennial or self perpetuating plant and animal species that were useful to man. A more current definition of permaculture, which reflects the expansion of focus that's implicit on permaculture 1, is consciously designing landscapes which mimic the patterns and relationships found in nature while yielding an abundance of food, fiber, energy for provision of local needs. People, their buildings, and the ways in which they organize themselves are central to permaculture. Thus, the permaculture vision of permanent or sustainable agriculture has evolved to one of permanent or sustainable culture. Permaculture was first a portmanteau or blending of two words, the blending of the words permanent and agriculture. And since its inception, it has come to also be a portmanteau of permanent and culture. The basic idea, and it is indeed basic, is to create a system of agriculture that is self sufficient, requires little to no work by humans to maintain, improves the land, and produces a product food, wood, fiber, animals that humans can use. And when I first heard of this concept, I pictured kind of the Garden of Eden. I thought it was a bit too ambitious. Raising food equals a lot of work and hard work at that. But the more I read and learned, I realized that this idea was very attainable. So here we have the permaculture flower, where it interweaves land and nature stewardship, built environment, tools and technology, culture and education, health and spiritual well being, finance and economics, land tenure and community governance, all being a part of the permaculture ethics and design principles. So, as we talk about these design principles, we find that there are 11 of them. Relative location. Each element performs many functions. Each function is supported by many elements. Energy planning, using biological resources, energy cycling, accelerating succession, valuing diversity, and designing small scale and intensive systems. We're going to use edge effects, and finally, attitude plays a huge role. First off, we have relative location. For example, compost setup would be located between the kitchen door and the vegetable garden so that we can allow for nutrients to flow from table to worms in soil and back to the table. And the second principle, elements perform many functions. So for example, chickens provide manure with nutrients, they eat bugs, they give eggs to sell, they provide meat products for sale. And as they scratch for pests and turn up the soil, they can suppress pests, they can provide fertilizer, they are a source of food and in terms of meat and eggs, and they cultivate the ground. So they have one element here that performs many functions. So another idea for something performing many functions, the area between curbs on your front yard can be utilized for more than just grass. They can reflect something that's more beautiful or be an insect habitat, a place for plant diversity, a soil building opportunity, a place for wild animals to forage or for you to forage, and for growing food. But ultimately, there's also zoning laws that might cause issues here. There's communal laws that you need to check to make sure before you start planting large native gardens. Each function is supported by many elements. So this includes things like pest suppression by chickens or allelopathic plant diversity, wildlife, healthy soil, or intervention. Food is created by chickens and crop plants and soil decomposers that create nutrients and compost biology. Land is cultivated by our implements, our animals, earthworms, and deep rooted plants. The fourth concept is energy planning. We take land area and develop zones based on the amount of time, work, input that is required to manage it. The highest requirements go near the house, which we refer to as zero, up to the unmanaged areas used for observation only, which we refer to as zone 5. We consider natural features of the land like contour, vegetation, aspect, and weather patterns when we come up with these plans. So here you can see zone 0, which would be the house, moving out to zone 5. In zone 0, the homestead or home center is located. Permaculture principles are applied here to create a sustainable area in which to live and work. In zone 2, we have a fully irrigated garden, personal and household elements which require frequent attention and visits. In zone 2, we have orchards that are usually irrigated and small livestock. Business and community elements may also be placed here. In zone 3, we have commercial crops, zone pastures and plantations, which are unirrigated, dams and large livestock. We have bioregional elements here as well. In zone 4, we're getting much further away from the house, and we have managed rangeland here. Forests and wetlands, national or continental elements can be designed here. In zone 5, we have our untouched wilderness. There is no human presence here except to observe ecosystems and natural characteristics. These are our global elements. So as we look at energy planning on a homestead, we can see here that the chickens are located along the daily path near the house, near which makes caring for them easy and natural. This is designed for sectors of land. So we have the house moving into various types of gardens, a food forest, raised beds. Zone 5 is really more of a wild area where they may collect wood. Zone 3 are their fruit and nut trees, and potentially firewood. Zone 1, flowers and herbs. Zone 2, they have shrubs, some berries, maybe some bamboo for quick building structures. Zone 4, again, they have their firewood and wild forest. We also need to consider slope and contour of the land and profile. These will play a huge role in how energy flows naturally. We want to work within this natural flow to make sure that our design makes sense. Using biological resources, all land has resources present and a careful eye can identify these. These come mostly in the form of plants and microorganisms. We can get a field guide to survey the land for useful and edible things. Hedgerows are often overlooked but highly useful. Chicken like to nest in this habitat. In the previous slide, we could pen the chickens in a long run on the sides instead of using valuable center space. Energy cycling is the sixth element. Our food system relies on massive scale extraction of energy like fossil fuels and fertilizers from the earth. It is a linear sequence of energy transfer that depletes our resources more quickly than they can regenerate. Permaculture seeks to transfer energy in cycles that build resources over time. We must seek to capture and cycle all energy coming through the land. Instead of relying on the manufacture and transport of chicken feed, we seek to provide food on site by planting and encouraging diverse life. Whatever we take, we must return. So here's another example of energy cycling where they've created an elevated dam above the house so that they can allow water flow down to where they need it without utilizing energy resources. And they have a natural transpiration energy from plants that are feeding back into the water cycle. Number 7, we use small scale intensive systems. Small systems require less energy to run, and we can stack more of them on a site for diverse yields. So intensive systems rely on lots of information to get them running efficiently. but run by themselves if properly set up. Instead of broad scale approaches like planting 2,000 acres of monoculture, we begin at the area closest to our living space and develop it to a point where it is functioning well with minimal input. We want to maintain control over our environment with as little energy as possible. Stepp Holzer's Kramaterhof is a great example of how much potential lies in small holdings. For chickens, we wouldn't want to start off with a massive flock, even if we have done extensive research. Starting small and really getting to know them will pay off when the time is right to go into larger production. Number 8, accelerating succession. We understand how stable biological systems are built over time in nature, and we can mimic this process successfully and quickly through permaculture design. The goal is to build stable ecosystems that produce a yield, usually in the form of multi-yielding food forests. So here you can see the stages of forest succession, from pioneer plants, which are generally annual, to perennial plants and grasses, moving into shrubs such as woody pioneers, and moving into short-lived pioneer trees, which we would call young forest. And finally, we get to our climax forest, which is referred to as a mature forest. Food forests are places to raise chickens, or basically areas that mimic woodland ecosystems that substitute edible trees, shrubs, perennials, and annuals. So in the upper level, we have our fruit and nut trees. In our lower levels, we have berry shrubs, edible perennials, and annuals. Wild berries grow along edge habitats of forests in Indiana. Can we capitalize on this growth system? Why, yes. Yes, we can. In this example, you can see a beautiful food forest where we have runner beans growing up a tree. We have pepinos being grown, strawberries along the ground, figs in the lower canopies, and pumpkins along the outer edges. The tamarillo plant is shown in the middle. All right. So we've been talking about permaculture and the design principles behind it, and now we're on design principle number 9, which is diversity. Diversity is natural and stable. It allows change to occur without detriment and increases production over time. Plants, animals, insects, and microbes basically all work and compete together to form the beauty that we call nature. And knowing the habits of a variety of organisms will allow you to place them together in a system so that they will complement one another. This is called a guild because the organisms create an environment allowing for the existence of more complex and abundant forms. So some examples. Pastures interplanted with trees have shown to be as productive for grazing as treeless pasture, with the added benefit of shade, fruit, nut, or fuel production. Our chickens do best not with a high quality bag of feed and a hut to sit in, but with a guild of bugs, plants, and microbes. Chickens should have plenty to eat and a mosaic of environments to live in. If one type of food or shelter is scarce, there are others to rely on in that environment. And so here's where diversity becomes important in agriculture. Um, Birds are an important piece of farm diversity. Everything gardens or has its effect on its environment. A lot of people don't understand the importance of bats in farming. They help decrease vectors like mosquitoes that bring in issues, especially I can't remember the name of the horse disease. West Nile in horses. The more bats you have, the less West Nile you're probably gonna have because they're taking out all those mosquitoes. So there's a lot more to diversity than what meets the eye, especially in farming. So here, for a forest garden, you would want a 7-level beneficial guild. You'd want your canopy where you have your large fruit and nut trees. So here in Indiana, that's like persimmon and pecan trees, or persimmon and walnut trees, for example. Your low tree layer, which are your dwarf fruit trees. These could be dwarf apples. There's a native plum here that I think would classify here. Herbaceous layer. These are your comfreys, your beets, your herbs. Your rhizosphere is your 5th layer, where you have your root vegetables. And then you have your 6th layer, your soil surface. These are your ground covers, your strawberries, etc. And layer 7, you have a vertical layer. These are your climbers or your vines. And generally speaking, they're going to be happiest at the base of the largest canopy trees. So, for example, Blackberries and raspberries do really well at the base of large trees because they like partial shade, and then they do especially well under walnut trees. They have like a complementary relationship with walnut trees. And if you look in nature, you'll often find them together. Edge effects are basically edges are the interface between two mediums where energy flows back and forth. So life basically exists as the effect of this flow. And so diversity is higher at the edge than in the middle of an area of evenness where energy is less immobilized. So when I'm talking about edges, I'm talking about like the edge of a field or the edge of a forest. It's these transition environments between different stages of nature or agriculture that we find the most diversity, and we want to make sure that we're managing our edges well. So as an edge effect increases, biodiversity increases. So the edge effect, again, the impact edge has an ecology of these two environments and the edge environment itself. Everything happens at the edge. So some more examples of edges: walls to a yard, house to a yard, sidewalk to a yard, fence to a yard, driveway to a yard, a planting bed to a yard, a planting bed to a fence, a planting bed to a wall, a planting bed to a wall, a planting bed to a house, a planting bed, I'm sorry, a pond to a yard. All of these are edge environments. And what we find is that nature doesn't like sharp edges. They don't like straight lines. And so we need to start making things wiggly. All right. So make all straight lines wavy to increase your edge habitat and therefore increase diversity. So some great examples are the keyhole garden bed or a mandala garden, which is basically a bunch of nested keyholes. We see the incredible terraces in the Andes and across most mountainous regions. There's a farming system used that basically uses a series of terraces that are a series of edges. And so we need to incorporate more of these elements. Other edges that we can consider. The edges between a shady spot and a sunny spot, either permanent or partial shade versus full sun. Having low pH soil, which is acidic, going into neutral soil. This occurs at the edge of pine trees, for instance. Planting beds that are on the edge of a large rock. The large rock, with its heat retention and moisture collection capabilities, creates its own microclimate and therefore another habitat edge. So more edge effects on number 10. This is a diagram only, but here you can see the same effect present in nature. The density and diversity of vegetation is highest at the interface between forest and grassland, where it's transitioning into another environment. This is an edge. I feel like I could make this like a really cool like saying, this is an edge, be the edge. Anyways, number 11, attitudinal principles. Oh, attitude is everything. So, failures are learning opportunities. And let me tell you, I've learned this so much in my career. Failed more than anybody. So, the negative effects of failure are minimized if we ask the right questions and learn from the mistake. Experimentation gains you experience, which is necessary to find the best way to do things. Every site has an abundance of resources in place in the form of wind, water, rocks, weeds, and wildlife. These resources become obvious with access to the right information. Creativity is the biggest limit to the effectiveness of a design. Chickens are destructive to the ground when penned in densely, but if this is our only option, we can use it to our advantage, such as clearing ground for planting by penning them in movable structures. Just like we saw at Constant Canopy, they would move the chicken pens throughout the inner row spaces to keep the Sudan grass down. And it was free food for the chickens. So organic farming, we're going to transition from permaculture into organic farming, although they really interweave quite well. In a USDA report in the 1980s, they found a growing number of concerns. So there were increased fertilizer costs, there was a decline in soil productivity, there was a degradation of the environment, hazards to human and animal health, as well as to food safety. Oh, there's a chat. Sorry, let me. So, organic farming itself includes a range of practice designed to eliminate chemical fertilizers and pesticides. It uses a practical use of crop rotations, biological controls, and other non chemical methods. It protects soils, human and animal health, food safety, all while improving the environment. But there is a long path to organic certification. It's costly, but it may increase prices that the consumer will pay for produce, um, because you won't be getting the same number of. A lot of people ask why organic costs more when it has less inputs. And the reason for this is because we are growing a lot less product, we're not able to stack it as closely and get as much yield because we're going to be fighting more pest pressures, we're going to be fighting more, weed pressures, etc., we're ultimately going to see a lot less product going to market. And as you know from any economics class you took ever, the less of something you have, the more it's going to cost. And so this is ultimately why organic products tend to cost more, because ultimately you're paying for how much more the farmer is going to lose. So Organic Foods Production Act of 1990, the OFPA, gave 3 requirements for people to get organic certification. They may not use synthetic chemicals in production. They may not use synthetic chemicals, on the land for 3 years prior to harvesting. And they must abide by an organic production and handling plan between producers, handlers, processors, and retailers. Now, I want to highlight something here because this is a huge misconception on the consumer's part. Notice that it says no synthetic chemicals in production. They may still use chemicals and pesticides, but they may not be synthetic. Okay, so this is a huge misconception that I get with students and with people that I work with in the marketplace. They think that organic means it's never been sprayed with anything or that it's never been treated, and that is simply untrue. Most organic produce is washed in bleach water because that's considered to be safe for organic production principles. It gets pesticide spray on it, it gets fertilized, all of those things, but it's not a synthetic fertilizer. It's not a synthetic pesticide. It's the more palatable forms of all of those things, the non-synthetics, the naturally derived things. And this brings me to OMRI, the Organic Materials Review Institute, who basically give the stamp of approval on everything that's allowed to be used in organic production. So it supports organic integrity by developing clear information and guidance about materials so that producers know which products are appropriate for organic operations. OMRI is a 501c3 nonprofit organization that provides an independent review of products such as fertilizers, pest controls, livestock healthcare products, and numerous other inputs that are intended for use in certified organic production and processing. So if you're going to make the switch to organic, make sure that everything's labeled with the OMRI label. But I've seen people use the OMRI label illegally, so also make sure that you check on their website that it's listed as something that's appropriate for use, because OMRI is always changing. So Organic 101, what is allowed and what is prohibited? And now this is another shocking thing for people, okay? So some synthetic substances are listed as exceptions to the basic rule and are allowed for use in organic agriculture. So for instance, pheromones have long been used as an effective non-toxic way to confuse insects that may otherwise infest organic crops, especially fruit. So likewise, vaccine for animals are important disease prevention tools against many infectious diseases, especially since antibiotic therapy is prohibited in organic livestock. So organic livestock still gets vaccinated. They just aren't allowed to have antibiotics. And when we get to the animal chapter, I'll talk about why I find that inhumane. But that's me imparting my own personal opinion. Okay, so they use pheromones. So things that are allowed and things that are prohibited. We're just going to go through a series of slides. So baking soda is allowed as a processing aid. It lightens dough for organic pancakes, baked goods, etc. Because most of the time people want a light colored dough, which is why rye doesn't sell as well, also because it has a much harsher flavor. But not everybody hates rye bread. I actually like it. Prohibited. Strychnine and arsenic are also, they're actually natural substances. So technically, We could use strychnine and arsenic, except Omri was like, listen, we're going to ban these. Even though they're natural, even though they fall under the organic label, we're going to go ahead and we're going to say that strychnine and arsenic are not organic. And that's fair. That was well played, Omri. Um, so they are prohibited in organic production. And all right, so the list. The National List of Allowed Prohibited Substances identifies synthetic substances that may be used and the non-synthetic natural substances that may not be used in organic crop and livestock production. It also identifies a limited number of non-organic substances that may be used in or processed, may be used in or on processed organic products. And there's the link for the list in case you ever want to go check it out. Basically, in general, synthetic substances are prohibited unless there's specific rules making an allowance for something for crop and livestock production. Otherwise, they're generally inhibited. Some substances on the national list may only be used in specific situations, only for a certain type of crop or up to a maximum amount or within a certain withdrawal period before harvest. Um, so some examples of things that are allowed: algicide, disinfectant, sanitizer, irrigation system, cleaning systems, alcohols, ethanol, isopropanol, chlorine materials for cleaning water, copper sulfate for disinfecting equipment. Some synthetic herbicides are listed but have certain concentrations allowed. Soap-based herbicides are allowed. The list goes on. So these are all things that organic produce are sprayed with. So you see there are some synthetic herbicides that are allowed. So this is a huge misconception on the consumer's part, I think. Most of my friends that tends to purchase organics, they truly think that there's like nothing, it's just naturally grown like that, and that it just nothing is ever sprayed or added or amended, or and that's just simply not true. But the things that are not allowed: ash from manure burning, arsenic, calcium chloride, which is used in the brining process, um, leaded salts. Well, that's cool. I don't really want to eat lead. I don't think you want to either. Potassium chloride, unless it's derived from a source and applied in a manner that minimizes chloride accumulation in soil. Sodium fluoroaluminate, which is a mind thing. Tobacco dust, strychnine, sodium nitrate, unless the use is restricted to no more than 20% of the crop's total nitrogen requirement. So, how many of you, if you could just tell me in the chat, or kind of farming? So permaculture, there's a focus on nutrient and water loop by using waste and reducing dependence on inputs. We have a creation of healthier soil and diversity of produce. There's a responsibility for waste elimination. There's a variety that keeps residents engaged and excited about growing their own food. It imitates nature. It's optimization of natural energies. There's nutritious food and habitat for people and native animals and birds. And there's a dependence on observation, mixed technology. There's minimal risk. If it fails, nature will simply take over. Um, I actually kind of find that principle to be a bit of a lie, because if you were to take an entire settlement of people and take away all grocery stores and say, all right, you're all going to survive on this land, and if it fails, you're not going to have food. So I think there is a little bit more risk than they imply here, but I don't think that many people are really doing permaculture on the level where they don't have a safety net, if that makes sense. So there's a difference in organic gardening and permaculture. In organic, we have higher yields per product but fewer products. The products will ripen at the same time. Pest control is closely monitored, and it's mostly human labor. Versus permaculture, which has a wider range of products including food, fuel, recreation, and habitat. The use of garden is to nurture the home, like to deflect wind and give shade and filter the air. There's water catchment that determines the shape of the garden. There's locally sourced and reused resources. There's integrated pest management, and there's a sharing of harvest with working animals. So more differences between organic and permaculture. In organic, we see the promotion of the use of natural fertilizers, making use of natural carbon cycles so that waste from plants becomes food for another. Permaculture uses organic gardening and farming practices, but goes beyond that to integrate the garden and home to create a lifestyle that impacts less on the environment. So it brings food closer to the consumers, brings consumers' waste back into the cycle, and it reduces energy wasted in transport. So if we were kind of comparing permaculture visions here between an industrial the industrial creation of a cup of tea is shown on the left, and the permaculture cup of tea is shown on the right. It kind of gives you an idea of just the concept that permaculture is suggesting versus how it's actually done right now. So in the industrial cup of tea, we see that the tea leaves are grown and boxed and flown somewhere, which uses oil, and then it's taken to a factory where it's bagged and whatever, packaged, transported to a supermarket where somebody goes and picks it up and um, actually takes it home and then uses whatever power source they have to heat the water to make the cup of tea, in a mug that was made also in a factory. Okay, so that's kind of like the whole industrial cup of tea idea. Whereas the permaculture cup of tea is saying, oh, I'm going to take this rainwater and I'm going to heat it in my wood fired stove from the hand cut logs that I got on the back of my lot. And I'm going to take my homegrown mint leaves and put them in my handmade or thrift store purchased cup. And I'm going to use solar and wind power to heat it up. Um, you know, in my locally sourced clay pottery cup, and then I'm gonna drink it. And so that's kind of like the drastic difference between industry and permaculture. So when is permaculture not organic? Local resources are used for permaculture rather than importing certified organic resources. So that means if there's a local resource that you essentially wouldn't count as organic, they're going to promote using that natural, whatever the resource is that they don't have to drive to get, whatever is nearby, even if it's not organic, they're going to promote that instead. So increasing diversity by bringing in unusual plant seeds from non-organic plant suppliers, um, that's another thing that they're going to do. Growing food plants along a river or roadside to filter out toxins and break them down to safer levels. We can't eat them, but we can keep them as catastrophe backup. So these are kind of some of the little nuances. So we want to foster a culture of community recycling when we're talking about permaculture. We want to use byproducts that would otherwise be wasted. So at Silk Farm, for example, they use recycled oil to make fire starters and the oil cans for simple worm farm towers. They're from a non-certified organic restaurant who sometimes uses leaves and fruits from their garden. This trade stimulates their local relationship and fosters a culture of resourcefulness. So, these are just some of the examples of what can be done. So permaculture actively converts resources. It weighs the benefits of using free local waste versus supporting a good organic supplier who may be in another area. Organic gardening may not have checks to reduce a system's impact on the wider natural system. So for example, you get horse manure from horses that are given anti-worming medication. You check if the anti-wormer is in the manure and if it can be broken down by high temperature composting, then remediate it before you use it. It's still better output than input.